everyone, welcome back to mahafarkar.co.in. In today's video, we are going to learn about angular momentum of rotating body. Before that, you should be familiar with the linear momentum. You know that we have already learned in a linear or a translational motion. Linear momentum is necessary to gain the force or gain the sufficient kinetic energy. In that case, linear momentum is given by product of mass and velocity. Okay, so if you just write this basic formula, the first formula that is required here is linear momentum in the translational motion. P is equals to product of mass and velocity. So according to the physical significance of moment of inertia that we have learned in some previous article, we can say that the mass here should be replaced by moment of inertia and V should be replaced by what? The angular velocity. In that case, we should have one important term, that is angular momentum in a rotational motion. So here in a rotational motion we have three important terms. For example, suppose like what we have considered previously, there is a body of mass m rotating about any axis passing through point O. Okay, so let that body is divided into n number of particles of masses m1, m2, m3 up to mn, and all are situated at different distances r1, r2, r3 and rn. Now every particle will rotate with different linear velocity. So linear momentum of each and every particle will be along the direction of velocity. We have learned that if this is the moment arm, then or radius vector, then velocity vector is always perpendicular to it. So along the direction of velocity, momentum is also there, linear momentum is also there, and therefore angular momentum is defined as the product of linear momentum. It is defined as what? Product of linear momentum and square of perpendicular distance. Angular momentum is defined as linear momentum and square of perpendicular distance, and therefore in vector form angular momentum can be written as vector L equal to R cross P. Why cross product? As they both are what? Perpendicular. So if in a magnitude if I write, then it will be Rp into sine theta, but as I said theta is 90 degree, therefore L equal to R into P. So this is the general formula for moment of angular momentum when we deal with the rotating body. Okay, let's derive its formula in terms of moment of inertia. To derive that, we consider a rigid body of mass m. There is a rigid body of mass capital M. This is rotating about an axis, rotating about an axis passing through point O. Passing through point O. Okay, let omega be the angular velocity. Omega be the angular velocity of that body, and we know that during rotational motion, if no external forces are acting on angular velocity, omega will be remain constant. So it will be remain what? Constant. Now imagine that the body is made up of large number of small particles. Large number of what? Small particles of masses that, like what we have studied for moment of inertia, say mass of first particle is m1, that of second is m2, last particle is mass what? mn, situated at distances r1, r2 up to say rn. Now the linear momentum of individual particle according to formula can be given by linear momentum of particle of mass m, of particle of mass m1 moving with velocity v1 is given by, say, p1 equal to m1 into v1. Say this is equation number 1 for this article. But what is velocity in terms of rotational motion? If you remember, but we remember that v equal to r omega implies v1 is equals to r1 into omega. I have not written omega 1. Remember, because omega is what? Constant. So, according to that, linear momentum P1 can be equal to m1 r1 omega. Say this is equation number 2. Now, we have the definition of angular momentum. Therefore, I will say angular momentum of this particle is, we are going to find out angular momentum according to formula. It is L1 equal to R1 cross P1, vector L1 equal to R1 cross P1, but every time vector R1 and P1 will be perpendicular. Therefore, I would write L1 equal to R1 into P1. Okay, substitute the value of P1 from equation 2. So we will get R1 into m1 r1 omega. That means it is m1 r1 square omega. So this is the angular momentum of first particle. So if I want to write for remaining particle, then I can write like, therefore angular momentum for remaining particles is, say, L2 equal to, according to this I can say m2 r2 square omega. L3 can be equal to m3 r3 square omega, so as Ln can be equal to mn rn square omega. Okay. So, total angular momentum or resultant angular momentum of rotating body, total angular momentum of rotating body can be given as L equal to L1 plus L2 up to Ln. It's simple. So just substitute the values from these equations. So we will write m1 r1 square omega plus m2 r2 square omega up to plus mn rn square omega. As you can see, omega is common, so I can write like this: m1 r1 square plus m2 r2 square up to mn rn square into omega. This term, we are familiar with this. We can use this summation symbol to write this: mi ri square from I equal to 1 to n into omega, and this we called as moment of inertia of rotating body, and therefore I can write L equal to I into omega. This will be the basic formula for angular momentum of rotating body. So we can use this formula in different forms. If I is different for different shapes, for rod, for ring, for disc, omega, if omega is equals to 2 pi n, therefore L can be equal to I into 2 pi n. This will be the another formula for angular momentum. Okay, so this is very important article in terms of CET. We require to understand the basic definition of angular momentum in terms of distance and linear momentum, that is given by r cross p. And according to the basic assumptions what we have used previously to understand the rotational motion, that body of mass m is made up of large number of small particles, and masses of that particles are m1, m2, mn, and all are situated at different distances, and all the distances are perpendicular to the axis of rotation. So the linear momentum of first particle will be p1 equal to m1 v1, v equal to r omega. According to this formula, v1 equal to r1 into omega. Substituting value of v1 in this equation, you will get linear momentum is equals to m1 r1 omega. So using the definition of angular momentum, what is the definition of angular momentum? It is r cross p. So angular momentum of this particle means the particle of mass m1 is L1 equal to vector L1 equal to vector r1 cross vector p1. But this rp sin theta, theta will be equal to 90 degree. That means 1 sin theta will be changed to 1. So L1 equal to r1 into p1. In that case, sorry, here it should be L1. In that case, we have written L1 equal to m1 r1 square omega. For the remaining particle L2, L3, Ln, we can find out similarly. Total angular momentum will be simply get added. Okay, so it will be like m1 r1 square plus m2 r2 square up to mn rn square into omega. This term in the bracket is summation of mi ri square from I equal to 1 to n. Okay, so according to that we got L equal to I into omega. So in that case, if you use another definition for an omega, that is another formula for omega, that is equals to 2 pi n, then omega equal to 2 pi n. If I substitute here, then I will get L equal to I into 2 pi n. This will be another formula. Okay. Now we will discuss conservation of angular momentum. Like if you remember, linear momentum is also remains constant or conserved if no force acts on it. In a similar manner, angular momentum of rotating body also remains constant if no torque acts on the object. If torque is constant, L is also becomes what? Constant. In very simple words, suppose any turntable is rotating with the same torque which is given to that. It may be increasing its velocity, it may be decreasing the velocity. In that case, it has to adjust the moment of inertia. For example, if you have seen the person who is doing skating, तुम्ही स्केटिंग करणाऱ्या मुलांना बघा, जर त्यांना त्यांची स्पीड वाढवायची असेल तर ते काय करतात, त्यांचे हात जवळ आणतात, पाय जवळ आणतात, बॉडी थोडीशी बेंड करतात आणि ते त्यांची स्पीड वाढवतात. पण जर त्यांना त्यांची स्पीड कमी करायची असेल, then what they do, they outstretch their hands, they outstretch their legs also. म्हणजे काय तर बॉडीचे जे पार्ट्स आहेत ते ॲक्सिस ऑफ रोटेशन पासून लांब नेण्याचा प्रयत्न करतात. बॅलेट डान्सर बघा, स्केटिंग करणारे बघा, यांच्यात काय चेंजेस करतात ते, तर इथं त्यांना काय कॉन्स्टंट ठेवायचं आहे, टॉर्क कॉन्स्टंट ठेवायचा आहे. टॉर्क कॉन्स्टंट राहिला तर एल सुद्धा कॉन्स्टंट राहणार आहे. म्हणजे काय, dl बाय dt इक्वल टू काय यायला पाहिजे, 0. आणि या स्टेटमेंटला तुम्ही म्हणणार आहात कन्झर्वेशन ऑफ अँग्युलर मोमेंटम. अकॉर्डिंग टू डेफिनेशन जर मी म्हटलं, देन इफ नो एक्सटर्नल टॉर्क acts on rotating body, no external torque acts on rotating body, then the angular momentum of body remains constant. Angular momentum of body remains what? Constant. That means initial angular momentum is always equals to फायनल अँग्युलर मोमेंटम. मग आता त्या स्केटिंगच्या एक्झाम्पल मध्ये मगाशी सांगितलं तुम्हाला, त्यांना अँग्युलर मोमेंटम सेम ठेवायचा आहे. म्हणून कधी वेलोसिटी वाढवणार, मोमेंट ऑफ इनर्शिया कमी करणार, तर कधी मोमेंट ऑफ इनर्शिया वाढवणार, वेलोसिटी कमी करणार. स्केटिंगच्या एक्झाम्पल मध्ये जेव्हा बॉडी जवळ आणले, बॉडीचे पार्ट्स जवळ आणले जातात, तेव्हा वेलोसिटी वाढवतात, मोमेंट ऑफ इनर्शिया कमी करतात. पण त्याच सिस्टीममध्ये जर त्यांनी हात लांब नेले, बॉडी स्ट्रेच केली, तर या कंडिशनला काय करणार आहेत ते मोमेंट ऑफ इनर्शिया वाढवणार आहेत आणि अँग्युलर वेलोसिटी कमी करणार आहेत. देअरफॉर इनिशियल अँग्युलर मोमेंटम से I1 omega 1 can be equal to what? I2 omega 2 and so on. या पद्धतीचे इक्वेशन तुम्हाला खूप गरजेचे आहेत. If I put value of omega 1 again in terms of frequency, then I1 into 2 pi n1 equal to I2 into 2 pi n2. 2 pi will get cancelled and I will get I1 n1 equal to I2 n2, or ratio of initial to final angular momentum I1 upon I2 can be equal to n2 upon n1. I hope you understood this. Angular momentum conservation चे बरेचसे ऍप्लिकेशन आहेत. स्काय डायव्हिंग करताना, स्केटिंग करताना, बॅलेट डान्सिंग करताना या सगळ्या गोष्टी तिथे कॉन्झर्व राहायला लागतात आणि म्हणून अँग्युलर मोमेंटमचं कॉन्झर्वेशन स्टडी केलं जातं. While rotation of earth around the sun also, angular momentum of a planet remains constant. आणि म्हणून तुम्ही बोहर पोस्टुलेट मध्ये शिकला होतात, ग्रॅव्हिटेशन मध्ये सुद्धा शिकला होतात की एरियल वेलोसिटी ऑफ प्लॅनेट इज ऑलवेज कॉन्स्टंट, कारण त्यांचं अँग्युलर मोमेंटम कॉन्स्टंट आहे. So these are some applications of angular momentum in our day-to-day routine. I hope you understood today's article. Thanks for watching mahasarkar.co.in. Have a nice day.